This lesson, we are going to be introducing some applications of derivatives. Specifically, we're going to be talking about maxima and minimas, highs and lows, basically. So let's kind of define this real quick. So in order to have an absolute maximum is the key, that if we have it at x equals some value c, that means that when you plug in c, that y value is going to be greater than any other y value, no matter what on that graph. Right? And the same holds true for a minimum. So an absolute minimum at some point, your y values are going to be lower than any other y value anywhere within that graph. So if you have some visuals, we're looking at a couple points of highs and lows. We have a point here, we have a point here, and we have a point here. Right, so those are some highs and lows, but let's define them. This one is going to be considered an absolute. So that's going to be an absolute min. This one's a minimum, but this one is what we call a relative min or a local min. Depends on what book is using what terminology. I call it a relative min, right? So it's not the absolute lowest point. This one's the absolute lowest point, but it's a low point. And then this one is a relative max. Because visually you can see the graph goes up forever, so there can't be any max at all. So there is no absolute max. All right, so it's really straightforward, especially visually. We'll have to do some math and do some calc in order to really figure out where some actual highs and lows are when you don't have a visual and you have some equations. But right now, we're just kind of focusing on the visual. So if you have just a chunk of a graph, an interval of a graph, here's where you're going to be talking about an extreme value theorem. So it says for all continuous functions, keyword continuous functions over a closed interval from A to B. So we have this point to this point. All right, every single one of them will have an absolute maximum and an absolute minimum, right? Because the graph doesn't go up forever. It has a high point and a low point. And your absolute maximums can be the endpoints. So that's your absolute max. And then this is your absolute min. And then these 2 points would be our relative. So a relative max and a relative min. Or local, whichever kind of terminology is used. All right, so that's an extreme value theorem. So that's kind of this visual right here. So every single one of these is going to have a high point and a low point, and they have to because they don't go up forever, they don't go down forever. And then over here, if you have this kind of a visual going on, you have an absolute max on this, but because it's not a closed interval, then this one does not have, so no absolute min. Because that wants to be the minimum, but you're not going to get to that point, so you can get infinitely close to it, which means no matter what you pick, somebody's going to pick something a little bit lower that's just closer to that point. So some other visuals we have. So for first example, so for the function below, identify the location of the absolute maximum values and the absolute minimum values of this interval. Do the functions meet the conditions for the extreme value? So it's got to be continuous, right? And we have to have a closed interval. So those are the two big things. So we have a graph that is continuous and it is closed because I can see the endpoints. Oops. Right? So we have a closed interval and it is a continuous interval. So because of that, we're going to have an absolute maximum. So absolute max. And we're going to have an absolute min. All right, so absolute max at x equals a, and absolute min at x equals c. And then here, it is not continuous. So we may not have both, right? Same thing here. This was not continuous, so we may not necessarily have both an absolute max or a min. So we do have an absolute max, So we have an absolute max at x equals c, but we have no absolute min. All right, so it kind of just depends on the situation. All right, so let's look at the last couple real quick. So we already talked about you can have local maxes and mins, which are relatives. So you have these points here, but it's not an absolute low point, but they are low points, right? So, and it doesn't matter if it's differentiable. We do have a maximum here. Doesn't have to be a smooth curve. So one last little piece is we have this visual, bunch of little pieces to it, and we're going to answer some questions. So it says we're trying to figure out the absolute and the locals, so the absolute and the relatives. So we have right here, this is an absolute min. And these two line up with each other, so they're both absolute maxes. So you can have two. And then this is going to be our relative min. Right, so the endpoints are just the endpoints on this, they're not absolutes. The endpoints can only be absolutes if you're going to define them. We were not going to call them necessarily relative because you don't have sides on, you don't have values on both sides. So we have an absolute max at x equaled q and x equals s, and then an absolute min at x equals p, and a relative min at x equals r. All right, so that was a brief introduction to some of that, maxes and mins and kind of definitions to them. And then in some next videos, we're going to do some math to figure these out if you don't have a visual.